Okay. So now that we are all in a pizza coma and are starting to settle in, I'm going to do some mental gymnastics. This talk is me showing you some kind of cool things that I've bumped into. One of the great things about being the head of engineering is that I can say we're going to do Haskell and we're going to do functional programming and we're going to do this and that. And assuming I can sell both my team and the board on it, I can actually get away with that stuff. We are one of the few companies I know of that actually do have Haskell in production, thanks to Brian Hurt, who's sitting straight back. And we will see some sample code. For those that, this particular talk is going to be about TypeScript and PureScript primarily, with, at the very end, because I ran short of time, because I thought it was 30 minutes, a few snippets that I pulled from Haskell just because I knew better how to do it in Haskell than in PureScript. For those that don't know, functional programming is this relatively new and cool thing that was invented back in the 1960s. And it is based on the concept of programming mostly as mathematics. So if you think of programming as attempting to resolve mathematically a particular kind of interesting problem, now you're digging at the space of functional programming. I have a long-winded presentation that I gave at NC DevCon a couple years back where I used that exact joke about it being in the 1960s. And I get it into at length why a lot of people think they do functional programming because they don't use for loops, and why that's not quite sufficient for functional programming, but it's a good start. And I walked through a specific example of functional JavaScript at the raw JavaScript level. So if you're upset that I'm not doing actual JavaScript, I'm instead cheating and doing TypeScript and PureScript, watch that presentation. If you want to follow along at home, the TypeScript install tsun PureScript, you have to install PureScript, and then you go to this URL and you proceed to walk through a whole bunch of steps. PureScript comes with a concept that everything should be very modular and you should only install the very minimal things that you need, which unfortunately means you spend a lot of time installing things that you need. My punchline in this entire talk, so if you nod off, this is the thing to remember, is that types can be declarative, not just descriptive. So what's that mean? Okay. Something that's declarative actually causes an effect to occur in the application. Something that's descriptive is describing effects that are occurring in the application. Okay? So for instance, JSS tags or the HTML bars that we just saw are declarative. Those particular tags actually are constructing particular elements in the application. So they're applied and they're actually describing it. On the other hand, TypeScript type annotations are descriptive. They are, in fact, just describing what should be going on in the application so that the compiler has some hooks in order to be able to perform some reasoning, or transpiler, or whatever you want to call it. It has some hooks in order to be able to apply some reasoning and catch some malformed code. So for instance, in this X string, you could take the colon string out, and that code would run just fine. It would, in fact, be JavaScript. But let's dig a little bit deeper into what this descriptive means. And hopefully, oh great, I get to do live programming this way, okay? Nope, we'll hang out in tsun. Okay, so let's take a look at that function that I just defined. Right, X string return json.parse X. Okay, it's undefined, so that's unhelpful. So let's ask what the type is. So the type of this function is that it takes in a string argument, which is called X, and it returns anything. TypeScript does not have a really convenient way to express that it's only going to be one of about 6 or 7 types. Notably, PureScript does. So instead of trying to create some kind of weird amalgamation, they just call it any and they move on with life. So it can return anything you want. Okay, cool. so if we do something like this, we get back foo2 as expected. If we do something like this, we get a compile error as expected. Okay, so let's try something a little bit different. Just a little bit different. Okay, so I'm now expecting to parse a JSON number, which of course is just a number, so it's a pretty uninteresting function, but there it is. We look at the type. Yes, I'm aware. Thank you for insulting me. Okay, so foo2 takes a string. I feel bad touching a really cool screen. Foo2 takes a string and returns a number. Okay, cool. So if we do foo2, I'm sorry that like everyone over here is like in a rear shot. It can't be avoided. Okay, we get 2 as expected. And now, let's see, if we do foo, something like that, we get our compile error as expected because that's not a string. It's a record containing a name foo, which points to a number. Okay, so far so good. So now we get to do the audience participation portion of this. Whoops. I just cheated you guys, didn't I? See, it still works. Jeez. Okay, and just because I'm trying to pull a fast one. So now let's do the audience participation portion of this. And let's say what happens if I do that. All right, everyone raise your hand. I want everyone, hands up, hands up. Good morning, hello, wake up, hands up. Okay. If you think this will throw a compile time error, put your hand down. Okay? If you think this will throw a runtime error, put your hand down. Okay? We've got some tentative hands now folding to the pressure. Okay? What do you think it's going to do?
I think it's just going to render.
You think it's just going to execute?
Yeah.
And return what?
Okay.
It's going to return object of foo:2.
Yeah,
Okay.
Same as the original one.
So if you think this crazy ass thing is going to, for some reason, totally lie about returning a number, and instead return me an object with foo:2, put your hand down. All right, we now got everybody. And assuming it doesn't crash, last time it did this. Oh, come on. That's so anticlimactic. Yeah. Actually, it was the second parentheses which caused the problem. Okay. And of course, now I'm running behind on time. Great. Okay, that's good. Foo:2. That's good. Foo:2. Single quote. Foo:2. Single quote. There we go. It totally lied to me. It says it returns a number. That ain't a number. That's an object. This is what I mean when I say types are descriptive. Okay, the types are describing what's already going on. When I said as number in the implementation, which I wiped off the screen, there we go. What TypeScript explicitly said I was doing was saying, it's a number, trust me, it's a number. If it's not a number, that's my problem. But for compile reasons, we're going to treat it as a number. At runtime, all bets are off. And whatever you get is whatever you get. Okay? This is what I mean when I say that they're descriptive. Now, I want to take a look at something slightly different. I'm going to take a look at PureScript, and I'm going to cheat a little bit and make sure that I know what I'm doing here. Yep. Okay, so I'm going to create a map. So string map, str map, is a map of strings onto whatever you want. Very convenient data structure in JavaScript land, right? So I'm going to create a string map, a singleton string map with one entry, which is foo, and 2. Okay, so this is a string map that points to an integer. That's the type of this thing. Okay. I'm going to encode that thing into JSON. So let's take a look at what y is. This is the JSON representation of y. Okay? So I've now got this thing hanging around as a nice little JSON structure. So let's go decode JSON y, and it's going to complain. One of the things you're going to have to get used to if you start entering into the functional programming world is that there is a lot of big explosive error messages. They're actually helpful, which is the one thing people are not used to about error messages. So you want a lot of content here. I'm going to skip through and basically tell you what it's complaining about is the fact that it can't quite figure out what this is supposed to do because it doesn't know what type to return. So I have to tell it what type to return. So I'm going to tell it return a string map int. It's going to complain again. And the reason is, oh, that's bad. Oh, I know what I did. I did my import wrong. Please forgive me. This is my bad. It's not a judgment on PureScript. It's complaining about that it wants its either string. Functional programming language. Side effect free. We're trying desperately to be so, at least in the case of PureScript. What either means is I might throw an error, which is going to be called left, or I might return something valuable, and since it's right, it'll be right. So it'll be one of these two things. So this case, I return something valuable. It's right, and it is specifically foo2, the pair, floating around as a string map. That from list is hanging around in string map. The nil means that's the end of the list. So there's only the one element, foo2, from list. Trust me, that's what this thing properly translates to. Okay. But what if I just want to say, keep it as JSON, but for some wacky reason want to just verify it? Now, I just do string JSON. Now I'm hanging out in JSON, and now I'm hanging out in JSON. I got back the JSON result. I executed the exact same code. In both cases, it was decode JSON Y, decode JSON Y. The difference was the type signature that I gave it, or rather the type that it expected to resolve. In normal code, you don't write the colon because the compiler can figure it out. It just knows what type that you want. And so as a result, all you write is decode Y. It figures out, oh, you want that type, and so I'm going to go over here, grab that type, and oh, there you go, now you got it. This is crazy. This is one of the coolest things that I discovered while starting to learn this stuff. So, let's see if I'm still in there. But hold on to your butts, because it gets even weirder. Types can also declare context, not just values, not just shapes, but actually context. In some code that I'm writing right now, which migrates from Couch to PostgreSQL, or Postgres, and I'll let you guess why I want to do that. I can specifically say that I need to be able to do some I/O operations. That's that funky monad I/O things, and I need to have a backup config. I need to do some I/O operations, and I need to have access to Couch. I need some I/O operations. I need to have access to pSQL, and the result is then hanging out on the right. But these three functions are then saying, this is a specific context in which I need to be executing. And it's the client's responsibility to make sure that I'm executing within the appropriate context. But guess what? Now I just specify my context. And if the type, or if the compiler can figure out any way to get me to that particular shape of a context, it'll get me there. This gets even cooler in some code written by Brian and Coda. Coda is sitting over there. Written by Coda using tools Brian built. So this is an API that we're running. What we do is we say, okay, we want to return an interest That's the big thing that we're looking for, or a list of interest, I guess. So we call data access layer.getInterest. Okay? GetInterest is defined as I need all this context. That's a lot of context. And then I'm going to return an interest floating around inside that context. So I call getInterest. I say I'm inside our database. Our database is named Helios. And then I perform this database query. Where do I convert to an interest? Interest itself has a specification as to this is how we get data back from the interest table that performs a conversion. The compiler says I'm getting a database query result here. Oh, I've got a definition for how to move from a query result to an interest. So now I can convert it into an interest. And now I can do that for you. What's even more is that line right there, get interest category, the result of that is JSON rendered to the user because the compiler knows how to take this envm handler interest noise, convert the result of that to a JSON object, and feed it out to the user. So we no longer have to implement any of that infrastructure. We just define the context and we move on with life. But guess what? It gets even weirder. I can actually tell the compiler, and it better get weirder fast because I'm almost out of time. I can actually tell the compiler, guess what? Perform some calculations to figure out where the heck to get values from, because I don't know how to do it and I don't want to keep track of it. So if I've got this base object and I've got all these wrappers and I've got all these, and I've got another wrapper on top of it called bar, and a few more wrappers, and then it's all the way up to foo. I can actually tell the compiler, if I have a foo and somewhere in this big pile there's a bar hanging out, grab that bar, and I want to use that bar. I want to move into that context. The code to do that looks like that, which by Haskell standards is reasonable and readable. Specifically, what it's saying is, in general, here's the implementation of how I'm going to move, and all I do is go up a step and call getBackupConfig again. So here's getBackupConfig. Eventually, if I actually have a backup config, what I will do is ask, which is to say pull that context out and use it. So it starts at the top at foo, and it'll go bounce, 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 bounce. Ah, have the context, stop here, because this is the one that's specified. So I think that's all pretty awesome and pretty amazing. I am, shall we say, frustrated when Java becomes the standard bearer for static types, because you can pull stunts like this and get power like this, and you can't in some of those other places. And I wish people would stop comparing, say, TypeScript to Java, and would instead start comparing things like JavaScript or Ruby to, say, Haskell, because I would think that's a much fairer comparison. Anyway, I think that's awesome. This is my Twitter handle. This is my presentation I gave at NC DevCon a few years back, where I talked about functional JavaScript. So if you want to see some real JavaScript, that's there. And this is a presentation that I gave to RubyMN, Ruby users of Minnesota, back in 2004, 5, telling them all that they should learn functional programming. So if you want to see some upstart kid be kind of a punk, that's a great little video to watch. All right, any questions, thoughts? I've got all of 2 minutes. 1 minute? 2 minutes. I'm taking 2 minutes. Anything? Bueller? All right, cool, thanks. Cool.
I'll give you a question.
Shoot.
Why is the last part of your presentation functional programming and the epitome